Good morning and good afternoon, everyone. Welcome to the webinar, Virtual Book Launch, Fundamentals of Machine Manufacturing Technology. My name is Mianmian Fei, and I'm the Junior Project Manager of Academic Relations at Swiss Next China, the Science Consulate of Switzerland in China. We connect the dots between Switzerland and China in education, research, and innovation. Today, we are very delighted to host the book launch of the very first engineering textbook co-hosted by Chinese and Swiss professors, Fundamentals of Machine Manufacturing Technology, published by the South China University Press. In the following hour, you will hear from the two authors from the South China University of Technology and SCUT, the University of Applied Sciences and Arts of Southern Switzerland, as well as the staff behind the book and Swiss industry representative about their lesson learned during the Sino-Swiss cooperation. We hope this webinar will inspire Chinese and Swiss researchers interested in similar initiatives. A kind reminder to our audience, at the bottom of the Zoom interface, you can find a Q&A function. Please type in your questions during the webinar if you have any, and we will answer them in the Q&A session at the very end of this webinar. Now, I would like to introduce you our first speaker and the co-author of the book, Professor Wangyu Liu. Professor Liu has over 20 years of experience teaching the course Fundamentals of Machine Manufacturing Technology to undergraduate students majoring in mechanical engineering at the South China University of Technology. In the past decades, she has led her team to build the course into the National Bilingual Model course and National Excellent Resource course. Professor Liu holds a PhD in mechanical manufacturing and automation from the South China University of Technology. She was also a visiting scholar at the University of Cambridge in the UK and a visiting professor at McGill University in Canada. Professor Liu, the floor is yours.
Okay, thanks for your introduction. And now I give several. Oh, sorry, I don't want to. Sorry, could you help me to play this? Because I do not find the button.
Professor Liu, so you can stop screen sharing and we will help you to share the screen from our side. So we will play the PowerPoints.
Okay.
You can stop screen sharing, yes.
Yes, yes. I don't find the button to play this.
Okay, you can just ask us to change to the next slide when you need. Thank you.
Yes, yes. Sorry for time to consume. Yes, my topic today is the introduce my course reform and the cooperation as textbook publication. And the first slide, you will see the bottom of this slide is the campus of South China University of Technology. And I think Claudia and Storm might be very familiar with this campus. So next, please go to next slide. Yeah. My talk today will cover the following sections. The first section, I'll introduce the background of course reform. In this picture, you will see that this is the traditional course structure in the past 20 years. You will see that for mechanical students, we have several or even many discipline courses. It will be divided into 3 levels. And the first level, we call it is fundamental courses. And the second level, we go to discipline courses. And the third level will be cover some other skills. And in the past 5 years, the discipline courses usually occupy almost 1/3 of the total teaching hours. So it occupies many hours in teaching. So we need to give a reform to the course structure. Now, please go to next. Next, yeah. So the background of course reform. Now, please go to above. Yeah, why we need the reform? Because there are some forces to drive the course reform. First is the external force driver, and the second is the internal force driver. For the external force driver, you know that China is a young industry country. Everybody knows that because in the past 50 years, we try to catch up with the advanced countries. So the external forces drive us to move fast. And because of the reason of historic reason, we inherit the system of the former Soviet Union, because in the past we have a very good relationship. And that is our structure, of course. So there's some shortcomings. And another reason for the external force driver is the overseas development. Everybody knows that the globalization of the world is very serious. So we have to move fast. So that makes our course have to reform. So that makes the whole country has a high education reform in China. I'm concerned about the internal force driver because of the big engineering. Everybody knows that engineering is not, this boundary is not so clear, and different disciplines try to combine together. So it makes our course have to make some change. So that is the background of course reform. Now, please move to next. So in this situation, we have to change something. So first, we have to reconstruct the curriculum system. So in the past, our course, especially disciplines course, occupy about 1/3 of the whole course. Now we have to try to reduce the teaching hours. For example, we have to cut down the teaching hours from 1/3 to only 1/4 or 1/5. So that is the background. And we have, for example, for our course, we have to make some change. So that is the mechanical engineering courses system. We have some fundamental courses and discipline courses, and also some compulsory courses and some optional courses. All right. Now let's go to next. Next slide. Yeah. So how to make the change? This is the main clue for the course change. In the past, for this book, we have 6 courses. So it could be divided into theory of metal cutting, cutting tool design, process planning of manufacturing, principle of fixture design, introduction to the machine tool design. So traditional 6 courses has to be combined together to make one course. So we need to make many changes. Please go to next. Next. So next, I'll introduce our publication history. You'll see that in South China University of Technology, we have very good foundation in metal cutting. And this is a paper from a famous professor Zhou Zhihua, who published his work in 1980s. And this is talk about the plan, growth, scale, and build-up edge, and their relationship. So it makes a very solid foundation for our teaching members. So that is a very typical work in our in South China University of Technology. Now, please go to next. That is the several books published by South China University of Technology. You will see that metal cutting serial, and we have 4 books it published in 1980s. So that is give us a very solid foundation in this course. Okay, please go to next. Next, yeah. And so after the course reform, so during 2001, 2010, and 2015, we published 3 books. You will see that this is the first book after the course reform, and we combined 6 courses together, including the knowledge necessary for mechanical engineering student. And this book is published by the Higher Education Press, and this is published by Huazhong University of Technology Press. You will see that we give serious change for the knowledge structure. Okay, please go to next. Now I will talk about some advantages of the past experience. First, I have to say we have a solid academic foundation in cutting that is represented by Professor Zhou's skill theory. And also we have a very early course reform among colleagues. For example, we have 6 courses compilation early in 1996. And also have some colleagues join our course reform, and we have at least 3 universities to join our course reform. And it was widely used by over 20 universities in China. When we have also won several honors since 2005, such as National Excellent Resource Sharing Course, National Bending Grade Example Course. So that is advantages for our publication. And please go to next. I also have to say we have some disadvantages. For example, this is given by some press to how many universities in China to use our book. Okay, about almost 20 universities. Please go to next. So why we need to publish current English textbook? Because in the past public history, you will see that there's several disadvantages because our book on in Chinese is difficult to be utilized by officers, engineers, scholars, and students. Also in China, we need to promote the English teaching, so we also need a English textbook. And it also lack of international view. The earth become a village, and I think globalization and internet and students exchange, information share, big data, all ask some new or English textbook. And it also lack of introduction of knowledge update, because engineering always driven by technology, such as knowledge explosion, new engineering interdiscipline, because we have to change, always change. So that is why publication has to be moved forward. Okay, please go to next slide. So how to write about ourselves to English textbook. And this so we get some funding. First, it's supported by South China University of Technology in 2016. and also get some funding from the publisher funding of South China University of Technology in 2017. And we also get some resources in the past. That is, we get a textbook imported in 2003. This is a fully English textbook, but it's written by American schoolers. So, but the system is not so familiar for us because, as I just said, that our course system inherited from Soviet Union, and we get some different systems. So, I think this book is not quite familiar for us, and in teaching, we find it's very difficult to use this textbook. Because please go to next. And in 2003, we also have some cooperation with Cambridge. Jim Platts is the supervisor when I visited Cambridge. So he reviewed our textbook and give us some suggestions to how to organize and writing and something else. So we published this textbook in 2003, English textbook. Okay, please move on. Next. So that is a very new story. Claudio came to our university since 2014, if I didn't remember, get the mistake. And he began to teach, give our students some lectures. So and join my course. So that is next resources. So I have to say some thanks to Claudio. When I decided to write the textbook, I asked him if he could join my writing, and he said, okay. So it gave me a very good encouragement. Okay, next. Next slide, please. So first, we need to design the book structure and how to make the new book more attractive or more advanced. So we have to design the structure. So that is, we have to inherit the traditional books because we have some advantages. I had said that. And we also need some update, all right? How to give some highlights to the new book. So we design this structure. It includes the fundamental theory of metal cutting and also some case study in process planning, machine tool, jig and fixture design. And that is a core link for different chapters. And about the machine accuracy surface quality is the goal. So we need the goal drive force and also have a core link. We have some case study at the end. So we combine these different chapters together to place them in a different position. And we also have to update and make highlights. That is advances each chapter and structure and some new material input. This is mainly contributed by Claudio, right? Okay, please go to next. So that is a view of the whole structure of the chapter. We'll see that we have seven chapters together, and chapter 1, 2 is concerned about the fundamental of metal cutting, and chapter 3 is about the process planning, and next, please. Chapter 4 is about the machine tool. Chapter 5 is about the jigger and the fixture. And these two chapters has many changes. Next, please. You'll see that chapter 6 and chapter 7 concern about the quality, including the accuracy and the surface quality. So that is goal driven to whole chapters. Okay, let's move to next slide. Okay, finally, I'll give some highlights and applicable scope of the book. And if you look back the structure of the book and look back each chapter, you will see that we have a development trend after each chapter. You will see that because manufacturing always changes with the technology development. So it couldn't stay on one side, one stage, and we have to move on. So we have to talk about some development trend after each chapter. And we also give some structure requirement. If you look into the textbook, you will see that it is quite different from our past publication, especially concerned about the process planning. And we have several books, but each book has different structure. And in this book, we divide the process planning and the jig and the fixture into 2 chapters. And we also put some knowledge point in different chapters, because during the teaching, we feel that it's quite very clearly divide the 2 chapters. For example, we talk about the jig and the fixture. It's always related with location and clamping, but location is also related with process planning. So in this book, we put the knowledge point of location into chapter 3, and concerning the location element and jig and fixture, we put it in chapter 5. So it sounds that they have different functions of location and jig and fixtures, but because that also has related with the process. So in this textbook, if you look into the whole book, you will see that it has some different. And we also put the machine tool, chapter 4, and after the process. You see, in the first book we published about in 2000, a machine tool is placed before process. But in this book, we put it after the process planning. So we make some adjustment of the structure because I have about decades teaching experience, and how to make every chapters have a good structure. We also give some change. Concerning about the highlights, and I think Claudio put some new material into the book, and also give some new element. For example, for jig and fixture, you will see that there are several different jiggers, example, in turning, in drilling, or in milling, and in grinding also has different structures. Also, finally, the application scope, and it could be for students and also engineers, machine manufacturing training students, mechanical engineering, material science, and from industrial design. And I think it could be widely applicable. And that's all for my talk. Thank you. And if you have any questions, please have it in the end. All right. Thank you.
Thank you, Professor Liu. Thanks for the interesting talk. And now I'm delighted to introduce the other co-author of the book, Professor Claudio Boër. Professor Boër had 2 decades of experience in Swiss industries and spent another 2 decades in academia and Swiss government agencies. In 2013, he retired from SCUT, the University of Applied Sciences and Arts of Southern Switzerland, as the Professor of Industrial Technology and Innovation, and is currently serving as the Vice President of the Board at SCUT. Professor Boër is a friendly ambassador to promote scientific and technological exchanges between Switzerland and China. Since 1991, he has participated in many cooperation projects with Chinese universities and industries, and is currently the senior advisor of Swiss Next China at the Consulate General of Switzerland in Guangzhou. Professor Boër, the floor is yours. Professor, you have to unmute yourself. Professor Boyd, we cannot hear you, so you have to unmute yourself. Thank you.
There, can you hear me?
Yes, we can hear you now, thanks.
Okay. Good morning, everybody from Switzerland and China, and I don't know if other country. Professor Liu just explained particularly the technical structure of a book and how we reach this present version of a book. In my case, I will be a little bit more open, and I will give, of course, some experience that I had, and particularly how the manufacturing is affecting the cooperation between our two countries. At the end, also some conclusion about what is and why it is interesting to write a textbook between two authors or more of the two countries. So first of all, 70 years of cooperation. This I will cut short because we had already a lot of events
sorry,
during
Professor,
last year.
You need to share your screen.
Oh.
Because we cannot see the PowerPoint.
What about now?
No, we just see you. So you have to click the green button. Yes,
And
it's
now?
working now, thanks.
Okay. There are so many social tools that I'm not used from one to the other one. Okay, so cutting short, this is the cooperation that we had during the last year, particularly between South China University and SCUT, but it is a cooperation that is already lasting many years. I put these figures because it's something that comes from many years ago. At the beginning, particularly in the industrial sector, there was some concern about the Chinese industry becoming stronger and stronger. But in fact, we were able through the cooperation to show to the industry that even if it is sometimes a kind of competition, but is also a winning. So a win-win situation can bring something new. I was involved with China from 1991. That was the first cooperation project in computer integrated manufacturing with Tsinghua University. And the project lasted 8 years. And during that time, also other university and company joined this program. Later, when I worked with Sino-Swiss, at the time was called CTI, Commission for Technology and Innovation, we also started a specific project that was called CTI China. It was very successful. It lasted also 8 years, and 15 projects were funded. Each country provided the funds for their respective partner, and according to each country rule, and many of these projects were in the area of manufacturing. In 2006, I think there is, for 2006, we started to create Swiss Next China, but in fact, it started in 2008 as official date. This had several implications for the cooperation. Several Swiss universities were able to sign agreement, and SCUT and SCUT particularly concentrated in the engineering field, as you have seen from Professor Liu's presentation. But we were also involved in other cooperation, for example, a precision manufacturing survey in Dongguan, the city in the south of China, and the Master of Science in Engineering and the MSc China, as it is called. Here on the right, you see just the brochure of the 2012 edition, but it's still running today, and Stone will give some more introduction about this. Very successful program. Teaching in China. I teach in several different universities, mainly in the south. My colleague Liu Wang offered me to teach, as you've seen, a course on FMT, and this was a particularly interesting experience because the methods and the environment are rather different. So here on the right is the first picture or first figure in our book. It looks very simple, a tool cutting in a workpiece that is turning, producing a chip. But when you have to teach this very simple phenomena in front of a student in a classroom, it's not easy to bring and make them understand. So what I did, I brought this. Probably some Swiss that are connected, they will recognize this. This is a typical cheese, of course, Switzerland, from a region of Jura, and is called tête de moine, or head of a monk. And normally this cheese is good when you can make a chip like a flower. And one of the workers in the company where I was consulting invented this little machine that makes the. So I try to use this with a student, and it's just a few seconds, you will see what happened. I don't know if you have heard the sound, but they were very suddenly, from looking just at the blackboard, they start to look at this and they start to understand immediately, intuitively, how a chip is formed. Of course, from cheese, I went to chocolate because they like it much better. But what is the future for manufacturing? Everybody thinks that manufacturing is something dirty or too much high-tech. But in fact, if we start from the past, and this is what one of the aspects I try to introduce also in the book, is the Swiss automatic lathe. This is a handbook, a date from many, many years ago, but the machine that you see here is still used today, and it doesn't need any computer. And I found one of these machines in one of my visits in a company in the neighborhood of Shanghai. And the name of a company is this one here, and is together with this company here. So manufacturing, for the people that are joining without knowing too much, manufacturing is the sum of materials, energy, and ideas. You have to take into consideration that is around 18% of the world economy. So it's a very large portion. It employs 300 million people, or roughly 5% of the world population. There is something that is in contrast with a service industry, that manufacturing is able to bring down the price of a product and not increasing like it happened very often in the service. And the table of life is clear. This table has many, many materials, starting from hydrogen, the origin of life, and more and more material will discover, and more material needed to be manufactured. I will not insist too much. But also the manufacturing itself in the world has changed. This is the trend of manufacturing in over 200 years. The red are the so-called rich countries, and the blue are the so-called poor country, at least with some kind of definition. And you see that the poor country that include at that time in 1800 also China, they were producing much more than the today rich country. And this has been going on, and now we are coming back. So this is some of the percentage. So in 1800, when the world manufacturing is starting, China was producing 33% of the world production. Then India, Russia, UK, and you see there is not even US here. This, by the way, is one of the first astronomical clock built by the Chinese. Then 1900, the situation is completely reversed. US is 24%, UK, Germany, Russia, and China is down to 6.2%. Finally, in 2011, I take this because it's the year in which really there is a shifting and China become world #1, US, Japan, Germany, Italy, for our Italian speaking audience, 2.8, South Korea and Brazil. And this is 2020. So you can probably look later if you receive the presentation. This is a quite interesting representation of world manufacturing output. So the percentage here are not changed too much. And if somebody want to know where is Switzerland? Well, Switzerland is in the 19th place with around 1%. Well, of course, Switzerland is a very small country compared to all this giant here. But, and our manufacturing output is of high precision, high cost. So if you look now to this trend, you can see how these are going down, Europe, US, Japan, and the black line is the growing of China. The textbook, just only a few words. Of course, from the teaching of the course, we try to put the experience in the textbook. The process itself to structure the book, as Professor Liu explained, Lucy, as we call her, is an experience. It took us already a lot of, sorry, I should have. It took us already many, I think 2 or 3 years to write the book together. But it's a good compromise between the wishes of the innovative textbook and the reality of consistency of the academic curriculum. This figure, I put it because this is the telescope that was not really invented by Galileo here, but it was perfected by Galileo, and he showed to the VIP of the time in Venice. And he was perfected because he was able, and this is taken by the preface of the book by Professor Giorgio Masiero, a friend, a colleague of mine. And he explained in this preface that really modernity was born 4 centuries ago from mechanical technology of production and cutting of new material. And it was Galileo that really pushed this idea and was the way in which the telescope was able then to show the new moon that was impossible to be seen by naked eye to him and to his colleagues. And this was in 1609. So you can understand it's a long time before to arrive. And in 2 years before arrived to China, a spacecraft called Galileo arrived to Jupiter, and we discovered many other things. So we always think that technology is a very fast process developing. It takes some time. So next, and then I will close, the next edition of the textbook. I don't think that reaching to a goal means that we have to stop. No, we have to go further. So the next edition, if Lucy, you want to do it with me or with somebody else anyway, is to understand how to integrate the engineering advances and transfer this knowledge to future generations. From our side, particularly from SUPSI and University of Applied Science, it's important to put together some basic practical experience, a little bit like I show with cutting of the cheese or the chocolate, how to experience this gain from the shop floor, how this can be brought on the theoretical background. Example, I suggest is exercise that start from real manufacturing operation and bring the student to extract the theoretical information that can be used in a more general context. So it's a little bit the reverse, not starting from the theory, but starting from the practical and coming up to the theory. The other, and this is based on my experience when I was teaching in other school in Europe, is that mechanical engineer is not so fashionable. But if you introduce technique like virtual reality, augmented reality, then it brings this much more. An example is this. This is a factory, a very modern computer integrated manufacturing for making shoes. You can see here. And this photo is not of a real factory, it is a virtual reality representation. And not only one photo, but everything is simulated. This will bring immediately the attention to the student to work in this field. So just as a conclusion, a textbook is, I think, is an incredible opportunity to bridge the cooperation between the two countries, in a specific field, but also as a general cultural understanding. And with this, I thank you, everybody. And at the end, if you want to ask questions, we are all ready. Thank you.
Thank you, Professor Boër, for your insights and for your contribution to the friendship between Switzerland and China. Our next speaker is the staff member behind the textbook, Mr. Shibodong Stone. Stone obtained his bachelor's in mechanical engineering and automation from the South China University of Technology and his master's in industrial technology from SCUT. He was the chief representative of SCUT in China from 2010 to 2014 and again from 2020. From 2014 to 19, he worked at Swissnex as the project manager at the Consulate General of Switzerland in Guangzhou. Stone, the floor is yours.
Yes, now I am coming in. So today I will share my experience study in SCUT and also in SCUT. Next slide, please. As already mentioned, I was a student from SCUT and then I go to Switzerland and studied there. And after graduation, I serve as a representative of SCUT in China and still now. Next slide, please. So when I study in Switzerland, when I study in SCUT as a mechanical engineering, I studied the basic things, mechanical drawings or engineering drawings, fundamental of cuttings, all the usual stuff, and everything is in Chinese. But at that time, there's already a reform of the teaching, so some English textbook was introduced to our majors. For example, this fundamental of machine manufacturing technology and other things. And very fortunately, there was also involved some other professors from abroad to come to SCUT for 2 weeks or 3 weeks teaching in China, which is very valuable for our life. And with this kind of English available technology, I was quite confident to say that I mastered the English in the mechanical engineering field. Next slide, please. And then the SCUT, go to SCUT and make a promotion of master study. And at that time, the master was called Master of Science Precision Manufacturing. I was the first trial, maybe we call it a white mice, to try this kind of cooperation. And then I go to Switzerland, continue my study. The master study was a little bit changed. We are more focused on project orientated and more on the CNC controls and the modeling and simulations. as I said, I have some English textbook as training, our confidence, but actually when I go to Switzerland, it's quite difficult for the language barriers. Next slide, please. For the language barriers, as I put a picture here, which is a tower. At that time, human race want to build and to reach the God, and the God is not accepting, and they put the people speaking different language, so they cannot cooperate to continue to build the tower. So next slide, please. So as before saying, I was confident in China. I already have some textbook training, but in fact, in Switzerland, starting with a full English teaching environments, I have some problems. For example, when we are talking about cam, what do you think? Is that a camera? No, in mechanical field, we talk about this cam, which is a kind of mechanism to control the travel of some movements. And then we talk about knife. In reality, we see a very nice Swiss knife for everything cutting, but actually in mechanical engineering, we are talking about a cutting tool to make the chip deformations of metals. And this is only the two examples I have to show, but there's a lot more. Okay, next slide, please. Hello, can you? But as China and Switzerland have important trades, you can see from the bottom, the values are growing from export or import point of view. Not only Switzerland, but also with Europe and USA, North America, and other world of the countries. It's very important to make the people understanding each other. In this picture, one of the important trades between China and Switzerland is this machinery industry. It's very important for the engineering from both sides in Switzerland and China to understand each other. They need to know what are you talking about. So next slide, please. Now it's very fortunately we have two professors one from China, the other from Switzerland, to co-authorize and written a textbook based on their experience, which is very meaningful for the Chinese student and both from the Swiss students, which they can get a common language and understanding each other. Because this textbook was a result of the teaching activities between the two professors. They already facing the Chinese one and also facing the Swiss one. It's easier for the student to understand the cultural difference, not only the technical terms. Next slide, please. So this is the end of my presentations. Thank you very much. If you have any questions, we will have a Q&A section later.
Thank you, Stone. And now after hearing about how this Sino-Swiss textbook had come into form, we would like to offer you some perspectives from the manufacturing industry in Switzerland. Our last speaker today is industry consultant, Mr. Marco Boccadoro, who works for Swiss manufacturing company, George Fisher Machining Solutions. Marco holds a master's in electronic engineering from ETH Zurich, and also teaches non-conventional manufacturing processes at the university. Marco, the floor is yours.
Okay, thank you, Chairman. Good morning and good afternoon, everyone. This short presentation is about EDM, electrical discharge machining. Why EDM? Because we are talking about machine tools in the end with this book, with this beautiful book, Fundamentals of machine manufacturing technology, and EDM is one of the most important machine tools technology. And you only have to check the number of papers published in Japan, in Asia, in all over the world. They are taking care of this technology. Next slide, please. But at first, 2 words about Georg Fischer. Georg Fischer was founded more than 200 years ago. It is listed on the Swiss Stock Exchange. It's present in more than 30 countries with about 16,000 employees. And you see the portfolio of technology. Basically, it covers almost everything that has to deal with machine tools. So milling, EDM, laser, additive manufacturing, and so on. And the markets are, for us, very important market of medical technology, aerospace, computers, electronics, energy, automotive. Next slide, please. Now, what is electrical discharge machine? The principle is very simple. It was invented in Russia many years ago, and it takes 2 electrodes, some liquid, and you bring these 2 electrodes one close to the other, and there is a huge number of sparks of discharges. So you can shape very hard metals regardless of their physical properties. And you generate pulses through a switch that is inserted in the connection between the generator and the plates. Next slide, please. So electrical discharge machine divides into die sinking process and wire cutting. Die sinking, it's copying what is carved in a electrode, usually about made out of graphite or copper, and you carve the negative, exactly the same copy in a negative way in a very hard material. And with this hard material, you make dies, molds and dies for injection molding, for die casting, for forging dies, for carbide tools, to make production in very large numbers. Now click please on the video. Okay, this video shows how you manufacture a keyboard for a laptop, for a computer, like Foxconn, for example, has 100 of these machines to do these keyboards and parts of computers. And down you see the part, the blank, very hard mold steel, and upstairs there is this graphite electrode where we carved the negative of the keys of the writing in the keyboard. You see the liquid filling up the working zone is a dielectric liquid. Now, if we bring the 2 electrodes, one close to the other, the sparks start. You don't see the sparks because it's under oil, of course. And we start mashing. Now you jump at the end of the manufacturing, you remove the liquid, and you see this is the mold used to prepare a keyboard. For example, here we wrote Georg Fischer Raji Sharmi, which is the brand name, just for to show an example. Okay, next slide, please. Now, wire cutting is also a very important technology, and it consists in a very small wire, which is about diameter 0.3 millimeter to 20 micrometer. You think that one of your hair is about 70 micron. So with one hair made of steel, we can cut very large parts of steel. This technology is used for cutting tools, extrusion tools, for electrode manufacturing, and also production. I show you later. Now, if you want to run the video, please, you see this wire surrounded by the sparks. And with this very tiny wire, we can machine a huge part. It is about 50 millimeter. And the precision of this technology is very high, about 2 micron on the finished part. Next slide, please. Now, the significance of spark erosion. Spark erosion was a game changer. Without EDM, the objects of our world would look like in the 50s, with very simple shapes coming from very simple molds, screwed together, many parts. A car would be made by many parts. And like Professor Boër said before, this technology brought probably the biggest deflation of consumer goods price, because thanks to this technology, complex molds are possible. There would be no low-priced cars, no iPhone without EDM. The surgery would be terrible, invasive surgery with very large wounds. Microtechnology would not exist. The world market is about 2 billion euro, considering only the high-valued machines. Next slide, please. About the world market, we see that the world needs every year about 350,000 machine tools. Of these, about 20,000 are EDM machines. And we have to add, only for China, 20,000 additional EDM machines with reciprocating wire. Is a special machine that was invented in Russia, and it's used a lot in China to make production of parts. Next slide, please. These are a couple of applications. You see knee prostheses, hip prostheses, syringes, dental technology, molds for even the ventilators that are used to cure the COVID-19 are manufactured by EDM. Hamilton is one of our big customers lately. Next slide, please. Okay, here we see the applications in aerospace. Very important application is FUR3 slots for turbine disc. You see the drawing on the left-hand side for aerospace parts. This is replacing another technology, which is broaching, which is a brutal technology, whereas with a wire, in a very elegant way, you can shape any kind of FUR3s. Next slide, please. Okay, in electronics, of course, as I said, the miniaturization of electronics would not be possible without EDM, microconnectors, iPhones, and so you see in the middle these lead frames for integrated circuits. Then a big market is also lenses for optical applications. The lenses that are in the smartphones are made by die sinking EDM. Okay, this is the actual situation. And now what about the future? Okay, the future of EDM looks a little bit like the future of other machine tools. And that's why I'm speaking about EDM today, among other reasons. Now, here you see the result of a big study that was launched by University of Aachen in Germany. You see on one axis the significance of the technology. On the other axis, you see the manufacturing share. And you see the situation in 2015 when this study was published. You see there are, I don't know, grinding, lathe, selective laser, melting, laser metal deposition, the additive technology is coming. And now if you click, you see what will happen in 2025. You see there are winners and losers. For example, 5-axis high-speed milling is going up in significance, and 3-axis milling is going down. All the additive manufacturing technologies are becoming more important. If you click once more, please. Okay, you see that EDM is still increasing its importance. So why is that so? Because EDM is a scalable technology, is a high precision technology, it's adaptable to any desired target. And any conductive material can be machined by EDM. Okay, this is about the meaning of the technology. Now, next slide, please. Now, how to predict the future? Predicting the future is very hard, as Niels Bohr said once. But we know there are forces that drive our world, these mega trends. And the forces we know, shorter product life cycles like customization, globalization, the demographic change, like aging of population, the biomedicine becoming more important, digitalization, this industry 4.0, cyber physical systems, resource efficiency, sustainability. This requires new competence profiles. New slide, please. Next slide, please. Okay. Now, on the left-hand side, you have the challenges, and on the right-hand side, this is the answers of machine tools, EDM, but also other machine tools. You see the changing worker profile was also mentioned by Professor Boër, and virtual reality, augmented reality, digital transformation is coming. Mass customization, so everybody wants a consumer good that looks a little bit different from the others. Biomedicine, and the machine tools must be ready to add to the machines the machine vision, for example, augmented reality, cameras in the machine tool, to increase the process performance in general, for EDM, but also for milling, for additive manufacturing. Apply the artificial intelligence, which is very powerful, to ease the job of the worker. The worker must do a most intelligent tasks and not be there and act manually on the machine tool. And then for mass customization, of course, you need automation. New materials are coming, like CMC for aerospace, ceramic matrix composite, that are impossible to machine with conventional cutting technologies, but are very easy to machine for EDM. So we have the answers, and these trends are valid for, in my opinion, every machine tool in future. So I come to the conclusion of my speech, and I thank you for your attention, and if you have questions, there will be question and answers.
Thank you, Marcos. Thank you very much. Due to time constraint, we don't have time for the Q&A session. But if you have further questions, please send them to the email address on this slide, and we will forward the questions to our speakers and give feedback to you. And you are also more than welcome to scan the QR code to follow us on LinkedIn, WeChat, and subscribe to our newsletter. Ladies and gentlemen, thank you so much for your active participation, and we look forward to meeting you in our next events. Goodbye. Bye.
Goodbye. Bye.